The repair project is a Horizon 2020 funded project which involves a number of academic and industrial partners, including Medtronic, which is one of the largest medical device companies in the world.
The idea began to rise to our mind during the development of liquid crystalline elastomers for microrobotics. Liquid crystalline elastomers, that we usually call LCE, are plastic material able to reversibly contract under external stimulation, thanks to the combination of properties from elastomers, such as the ability to support and respond to stress, with those of liquid crystals, such as the ability to respond some way to external stimulation. The result is a plastic material able to reversibly change shape when the liquid crystalline molecules inside it organize in ordered or disordered phases upon external stimulation, and such stimulus can be light, temperature, and so on. Our stimulus of choice is light, green, efficient, and it is possible to shine it on really small assembly with selected wavelengths and intensity. And the other crucial point of the material is the organization of the liquid crystalline molecules inside. By programming the alignment, it is possible to obtain different movement in the final material. In our microrobots, the LCE part is the muscle that contracted under light illumination and relaxed back when the stimulus was switched on, allowing the microrobot's movement. The repair idea is to develop such material to obtain patches able to help a diseased heart and restoring the cardiovascular function.
In the project, we aim to develop light-activated contractile patches which can be sutured onto the exterior of a heart and in such a way assist a sick or diseased heart. The films are very thin. They are in fact only 10 micron thick, or that corresponds to 1/7 of a human hair. And even though the films are very thin, they can actually develop a specific tension, or you could say force per cross-section, which exceeds that of the human muscle tissue. So, but as I said, the films are very thin, so only 10 micron, and that means that we need to form a stack of alternating layers of films and light-emitting diode arrays, which will actually illuminate each of the layers of the LCE film to make them contract. And when they contract, they basically can either support the cardiac contraction or they can replace, you could say, a non-contractile part of the heart.
Therefore, many different competencies are needed to develop such devices. We take advantage of knowledges from chemists, physicists, physicians, biotechnologists, engineering, and so on. Too many to be all mentioned. Surely, having on board big and small companies is the key point to get the final target, the patients.
Medtronic is a part of this project because we feel the obligation to support, you could say, the welfare of the human beings. But let's also face it, Medtronic is a commercial company, and we also have an interest in novel technology which can be used to serve our patients.
But why did we focus on muscles, and specifically on cardiac muscles?
We as humans can only exist because we have muscles. Think about it. If we wouldn't have muscles, we are not able to scratch ourselves if we have an itch, for instance. Or maybe more importantly, our heart is a muscle. The heart is always beating, beat after beat after beat. This takes a lot of energy, of course, so there must always be a balance between the energy which is used and given. And sometimes this goes wrong. For instance, when a little clot goes to a vessel in the heart, then we get a heart attack, which is familiar to most of us. And the way for the heart to repair this is to take out the diseased piece of heart and replace this with a scar. But a scar is not a muscle. So as a result of this, the heart is weakened. We as a group of scientists work together in this repair project to apply this LCE technology to help patients who have a weakened heart. So we really work hard to get maybe one day this technology applied to patients who had a heart attack. Or we can also think about other heart diseases, like patients who have atrial fibrillation, which is maybe less common, or heart failure. All of these conditions, situations where the heart is weakened, and an additional support may help the heart. So we are on this fantastic journey, and we hope that we can really bring this to the clinical care.